Hello to today's lesson. We're still working with the notes page for section 7.2, so you should have that available. And we're going to continue then later with our skills practice 7.2. Today we're going to find that in some of our work, we're going to end up with negative exponents when dividing monomials. And so we need to look at what is happening and what do I need to do in order to work with the negative exponents. So one thing you need to keep in mind is our rules that we were working with before. We had x to the fourth, let's say, over x to the third, and our job was to simplify by reducing our fraction expression here. And the shortcut rule I taught you was we take the numerator's exponent and we subtract from it the denominator's exponent. And that left us with x to the 1, or also known as x. What's going to happen today is we're going to get some negative exponents. What we need to know in our simplified expression, this is the simplified expression, that in our final answer, there can't be any negative exponents. So that is a big thing to know, is that in a final answer, there can't be any negative exponents. Let's begin. All right, so let's take a look at the example first, and then I'll go back and explain the rules of this concept with negative exponents. So here I have an example of 8 to the second, which is equal to, or divided by 8 to the fifth. If we use our rules that we just reviewed, that means I'm going to take 8 to the 2 and I'm going to subtract from it the 5. Well, when I simplify that, I'm going to end up with 8 to the negative 3. I can't have a negative exponent as a final result, so this is not done. So what we need to do is we need to take a look at what's going on here and how my answer is going to really appear, and then apply that to the rules that we have. So we have, remember, longhand, 8 times 8 in the numerator, and we have 8 times 8, 5 times in the denominator. And when we looked at this previously, we knew that our goal was to simplify out those things that were alike from the numerator to the denominator. So we had a pair of 8s and another pair of 8s, which left us with 1s in the numerator. And so here I just have 1 times 1, which is equal to 1. Down here I have 3 8s left over. This is a little different from before, where my values are left in the denominator rather than the numerator. Okay, now this expression here is the same as this expression over here. So that means that the final answer over here has to be the same as the final answer that I got when I did it longhand. And so when I get a negative exponent, that tells me then that I'm going to take my base to that exponent, but I'm going to move it to, in this case, the denominator. And so anything to a negative exponent is going to move that base position in the fraction. In this case, it's going to move it to the denominator. Now, we know this is not simplified. This is actually going to be 8 to the third is 64, 512. So this is actually the final answer. We'll take a look at some answers with variables in them in a moment. So let's go up to our rule. So it says here in our rule, it says for any non-zero number a and any integer n, it says that a to a negative power is equal to 1 over that a to its positive power, which is what we saw happen with 1 over 8 to the third. Now, it's true for the inverse. What happens if I have a negative exponent in the denominator? So if I have a base to a negative exponent in the denominator, then that value, that a value, is going to move to the numerator with a positive exponent. So it switches its place in the numerator. What it does is it actually takes it reciprocal. We call that its inverse. And so you got to keep in mind, if it's in the top over 1, it's going to move to the denominator. If it's in the denominator, it's going to move to the top over 1 in our expression. Let's take a look. So here we have an example. This one has all variables. And now I don't have any common variables between the numerator and the denominator in this example here. So if we apply our rule that says that a to the negative n is equal to 1 over a to the nth, and we have 1 over a to the negative n, that is equal to a to the nth over 1. What I can do is, in this case, here we have that -3 and we have that -5, they're going to move place. Now, C is to the positive exponent, so he actually is going to stay where he's at. He doesn't have to move. I don't have any other C's to worry about collecting together. But this b to the third, because -3 is on the top, he's going to move to the bottom. So b to the third is going to move to the bottom. The d to the -5th is on the bottom, so my rule says he moves to the top. So d to the 5th will move to the top. Final. Now we're going to get ready and we're going to tackle the skills practice worksheet.